Today I want to look at the notion of the limit because the limit is the first thing you will learn in your calculus course. Maybe not, I haven't taken every calculus course in the country, but in most of them it will be the first thing you learn, and it's going to be one of the most important things you learn. It's something that you will continue to build on as you go throughout calculus, so it's important that we understand what the limit is and what the limit isn't early on, right? So as you can see, we have a function of x defined. X squared minus 4 over x squared minus 4. Now, what might this look like? Well, we all know that if you divide something by itself, it's equal to 1, right? 5 divided by 5, 3 divided by 3, negative 5 divided by negative 5, they're all equal to 1. So surely, x squared minus 4 divided by x squared minus 4 is going to be equal to 1 no matter what x is, right? Now, that would be nice. However, there are a couple exceptions. We can't divide anything by 0, right? We can't do 4 divided by 0 or 0 divided by 0. And unfortunately for us, at x equals 2 and x equals negative 2, our denominator evaluates to 0, right? It's because when you plug in either values for x, we get 4 minus 4, and that's 0. So we have a couple of exceptions, but, for the most part, our function is going to be equal to 1 anywhere else. So let's draw this, right? Let us draw this beautiful y-axis and then its beautiful x-axis. Let's name a couple points, 1, 2, negative 1, negative 2, and then we'll have 1 on our y-axis, right? And let's draw the graph of this function. Now remember, we agreed this is equal to 1 anywhere except for negative 2 and 2. So, we got to negative 2. We're going to put a little hole here to note the discontinuity. That's a word you'll need to know in the graph. And then, another hole to note the discontinuity at x equals 2. And then this is going to continue to be 1 anywhere else on the graph. So what are f of 2 and f of negative 2, right? What does that actually evaluate to? Well, f of 2 and f of negative 2 are simply undefined. That's a completely acceptable answer. You say that the graph is undefined, or the function is undefined at those points. Now, let's look at the limit, right? Because how is the limit going to start to shake things up? Well, let's say we want to look at the limit as x approaches 2. So x is not equal to 2, x is approaching 2 of our function of x, right? So, well, let's just approach 2. Let's see what happens, right? If we approach 2 from the left side, right, our function is equal to x. Our function is equal to 1, the entire time, just until we get to 2. And the same is true for the right side. When we approach from the right, our function is equal to 1 just until we get to 2, right? But remember, we're not looking for f of x when x is 2. We're looking as x approaches 2. And this is where the limit is different because that means we have found that our answer is going to be 1. And remember, we said f of 2 is undefined. When you plug 2 into f of x, you get 0 divided by 0, and that is undefined. The difference with the limit is that we are not actually at 2, we are simply approaching 2. And as close as we get to 2 from either side, so if we have 1.9999999 or 2.000001, f of x is going to evaluate to 1. And so that is how the limit works, right? Now let's look at something else, right? Let's do another example to hopefully get this point across. So I have another function of x defined here. So f of x is going to be equal to x except when x is equal to 1. So x cannot equal 1. And then our f of x is going to be equal to 3. That's supposed to be a 3 when x is equal to 1. Now this is a very strange function, but I made it up, so we're going to look at what it actually looks like, right? So let us graph this one last time. Let us make a graph. We have our beautiful x-axis. We have our beautiful y-axis and then our beautiful x-axis. And we're going to name a couple points. We're going to call this 1, 2, 3. We don't have to do the negative side. We'll go 1, 2, 3, and then, yeah, that should be good. So f of x is going to be equal to x the entire time. So we'll have a perfectly straight diagonal line, right? So let's draw this. We're going to do this in our turquoise color. So a straight diagonal line. And then remember, x cannot equal 1. So we're going to go back and change that. So this is what our function is going to look like in both directions. It's going to go straight diagonal in both directions, except at x equals 1. Here, let's get a different color. So at x equals 1, there's a discontinuity, right? There's that hole, right? It's an empty hole. But at that point, we define that x is going to be equal to 3. So this is hopefully going to drive the point home about the difference between f of x and the limit as x approaches a certain number, right? So clearly, f of 1 is going to be equal to 3. I mean, we defined that, right? We said f of x, right, is equal to 3 when x equals 1. So let's write that out. f of x is going to be f of 1 is going to be equal to 3, right? Now, what about the limit? The limit as x approaches 1, right? How is this going to differ for f of x? Now, I probably should have used a different color, but that's fine here. We're going to go to green. So as x approaches 1, as we get closer and closer to 1, right, our function of x is going to approach the number 1, kind of like in our last problem. That's just a coincidence. It's not your limit is not always going to evaluate to 1. But we're getting closer and closer to 1, you know. If we plug in x equals 0.8, then f of x equals 0.8. If we do x is 0.9, then f of x is 0.9. If we do 0.99999, f of x is 0.99999. So we're getting closer and closer to 1 as x approaches 1. And the same is true from the right side, you know. When x is 2, f of x equals 2. When x is 1.25, f of x is 1.25. When x is 1.000001, f of x is 1.000001. So we're getting closer and closer to 1 from both sides of our equation. So clearly, I mean, I would say that we can say that this limit of f of x as x approaches 1 is equal to 1. Now notice how that differs from our clearly defined point right here, that f of 1 is equal to 3. But the limit as x approaches 1 is something entirely different. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.